Now we're on to 7.2, the law of sines continued, okay? What we're going to be talking about today is our ambiguous case. Our ambiguous case is solutions for when you have SSA, so side-side angle. We deliberately write it backwards because if we went the other way, it would be don't backwards, right? And so therefore we write it as SSA triangles, not the other way around, okay? And go for there. So we are given the lengths of two sides, right? And the angle opposite of one of them is a case 2, which is SSA, okay? Then there's either 0, 1, or 2 triangles that can exist from here. And the reason being is it depends on where your height of your triangle lies. You close the door. Okay. All right, so does this make sense? If I'm only given this piece of information, then something has to be given. So there are options of how it looks. So you see right here, if my if I use law of sines and my sine of my angle B is greater than 1, that means that my height is between the values of the side A and side B. Then I have 0 solutions. There's no triangle possible. Okay. If the sine of my angle B equals 1, that means it creates a right triangle. And my height and the height is whatever side A is. The next one is an obtuse triangle. If the angle B, if the sine of angle B is between 0 and 1, and side A is greater than side B, then I'm going to create one obtuse triangle. And then the last one is a special case triangle where it produces 2 triangles in one. And so that means you'll have 2 A values coming out. So you have to pay attention to the value of your B. Okay. So if sine of B is greater than 1, we know that it's going to be a 0-case solution. If sine of B equals 1, we know that we produced a right triangle. That's because at 90 degrees, that's the sine of 90 degrees. 1, right? So we produce a right triangle. And if the sine of B is between 0 and 1, then we produce a triangle that exists. And then if B is between 0 and 1, but these two things are true. Your A is less than your height, greater than your height, but less than your B, then you have actually 2 triangles that you're analyzing. Okay. Now, this is all because your A value is acute. Okay. And because A is acute, that's what we leave so many values of the angles being left open, right? There's between 2 angles, you can make 180 a lot of different ways. Not 180, what's remaining from 180. All right, now, if A is already obtuse itself, so if A is obtuse, meaning that it's an angle greater than 90 degrees, then you have no solution if your sine of your B is greater than or equal to 1. And you'll have one solution if, now or later, we're just applying it. We're going to apply it. You may need it later. Well, we can go back. Sine B is between 0 and 1. So basically positive. Okay. Yeah. And here we go. It's just better to look at it. All right. So you're going to apply the law of sines for any angle of a triangle. When their sine theta is between 0 and 1, that's because when you think about the sine function, what is our max value that we can go up to? 1, right? The sine max. 0 and 1. So we're not looking at the negative. We're only looking from 0 to 1. Sine theta equals sine of 180 minus theta. They're supplementary angles. And the smallest angle is always opposite of the shortest side. The largest angle is always opposite of the larger side. And the middle is obviously such and such. Okay, now let's dive in. So we have this triangle. We have triangle ABC. If B equals 54 degrees and 40 minutes, side B equals 8.94 meters, and side A equals 25.1. What's the first thing I said you should always do when you're given the values? Draw the triangle. So I'm going to draw and label my triangle. If my pen lets me. It's like, no, not today. Oh, like I saw this, you couldn't just do what you just did. Because it's angle side, you have to check your sine of your B first. So we're gonna explain why in a second. So we have A. This is just a preliminary script. We know that B is 55 degrees and 40 minutes. We know that side B is 8.94. And we know that side A is 25.1. Okay, so we have a side-side angle situation. So the law of sines can be written either way, upside down or however you want to write it. Doesn't matter. The ratios, as long as angles are together and sides are together. Does that make sense? Okay. Now, when I set it up, I'm going to plug in these values. So I plug in what I know. So far, we're normal, right? Why did we switch it? It doesn't matter. It's just showing you an alternative way of seeing it. Like we can still do A. Okay, so I plugged in the values. Now, because it's side A, I'm going to check the sine first. The sine of 55 degrees in 40 minutes. So I keep going, and this is what we have. Sine A equals, because we cross multiply and what? Divide. Are we comfortable with what sine A is? Okay, we're going to check the value of our B. I'm going to go to my handy dandy calculator. Got to make sure I'm in what mode? Degree. And I'm currently in radians, so I'm going to switch to degree mode, hit enter. And I'm going to put in sine of 55 plus 40 over 60. Are we okay with that? Everyone's with me so? I'm going to press enter, and I get 0.826. So I have an acute. I can't talk to you right now, Randy. Huh? I plugged in, going back to the table. So now, I went back to my table. All right, so I know that it's possible because the sine of my B is no, not there yet. I'm sorry. I did something wrong, guys. Scratch what I said. You actually gotta do it. We gotta do sine of A. I forgot it switched. It's not a B. It's A right now. You're just gonna plug that in. Silly me. Into the calculator. And once I plug it in, I'm gonna get a value, just like usual. And this is 2.31. This is the angle we're looking for. Sorry, not the angle we're given. It's backwards in our notes. So we get that sine A is 2.31. And if the sine of the angle you're missing is greater than 1, that means what? Let's go back. If the sine of the angle you're missing is greater than 1, it means what? It's not possible. There's no triangle exists. Okay, so the angle that we were trying to find And therefore this doesn't exist. Okay, because it's greater than 1. Because that's what you're you're using I said I messed up. I looked at it using the original rules where we were given our A and we were searching for B, but it was reversed for this problem.
So like
We're
it
searching.
doesn't say that we're trying to find A.
It says solve the triangle. So in order to solve the triangle, I need to find all unknowns, right?
Yeah.
A, B, C, whatever's missing.
If we started with B.
I don't have enough information at all to start with C. I can't do nothing to C.
Oh, because you already have A.
Yeah, I can't do nothing with C. Yeah. Okay. So this triangle does not exist because the sine of the first angle I tried to find is greater than 1. So that no such triangle exists. So this is what it would look like. So if I was to actually put in the measurement, it would be too short. They won't connect. And that's why there's no way of drawing this out. If I made it the actual distance that it's saying that angle is. Does that make sense? All right. So we're given two sides and angle opposites. So anytime you're doing that, you have to be careful and conscious of what's happening to the sine value of the unknown angle you're getting first. Okay. I know in our notes it says sine A, sine B, because you're assuming that you're giving A, but you could be given C and you need to find B. You could be given A, you need to find C, right? It's just the angle that you're searching for. The first angle is what you're looking at and comparing to. Okay. All right. This one goes with our notes. Here we go. Let's try it again. So we have triangle ABC. And as you can see here, we're trying to decide, solve the triangle. So solve for everything that's missing. I'm going to draw my triangle. Hey, I mean, that is a pretty decent little triangle I drew right there. Just want to point that out in case y'all didn't notice how well I did that. Okay. Okay. And I know that across is 22.8. And I know B is 24.9. Do I know anything about C? No. But I have a side-side angle situation. So side-side angle, which means that once I get to the point of plugging in, I have to evaluate what that sine is. Got it? Okay, so we're going to set up our ratio. I'm given all information for A, and I know side B. So when I plug in and isolate. Now, when I plug this into the calculator, I'm checking to see if it's greater than 1, between 0 and 1. And then I got to compare the sides. So we plug it into the calculator. And let the calculator do the work. And we get it's approximately 0.8978678. So what does that tell me? That there is a possibility, right? There's a possibility of a triangle. Okay, now that there's a possibility, I really should have made a little miniature version because I really don't want to go backwards to the chart. I need to go back to the chart. Is it okay if I go backwards to the chart real quick? I'm gonna toggle back.
Well, we found sine B.
We found sine B. So our sine B is between 0 and 1. Because it's between 0 and 1, there are two options here. It's either going to, you got to look at your A. If your A is greater than your B, then there's one solution. Okay. If your A is less than your B, then there's going to be two solutions. So when we had, what are our values? What's the relation between our A and our B? A is less than B. Perfect. Okay, so we look here, our A is 22.8, which is less than 24.9. Yes? So that means we're going to have how many solutions now? 2. There's two possible solutions. It's because our A is less than our B. Okay, and our B is less than 1 but greater than 0. So it exists. A triangle exists. Either one triangle exists or two triangles exist. That's the first thing. Once we decide that it's two triangles. That's because our A is less than our B. Okay. So there are two triangles between 0 and 180 that satisfies this equation, which makes sense because sine is positive in quadrant 1 and quadrant 2, which is from 0 to 180. Does that make sense? So we're going to find the first one, and then we'll find the second one. So in your calculator, you're going to actually do the inverse sine to find your first angle. So we're going to do the inverse of sine, which is going to be second sine inverse. And that's that 0.89786 to find the actual degree value. Remember, the inverse tells you your angle measurement. So in quadrant 1, our angle is 63.879. Therefore, in quadrant 2, it has to be 180 minus that value. Does that make sense? And our second angle is going to be yes. Okay, so what we did is we found our first angle, and we're going to roughly say 63.9. We round at 63.9 because our original angle is also round to the nearest 10. Because we know it's 63.9, then our second option for B is 116.1. If I have two options for B, that means I have how many options for C also? 2. So we have our 2 B options. Now we got to find our 2 C options. Make sense? Yes. No, tell me. Oh. We did the inverse. So we did the inverse of sine, found our quadrant 1 value. Then we subtracted that reference angle in quadrant 2 and found our quadrant 2 value. So now we have our 2 options for B. What do you mean?
Like one of them is 63.
Yes. Yes. These are my 2 B options. So B can either be 63.9 degrees or B can be 116.1 degrees. And that's because my A value is less, the side A is less than side B. And there's 2 ways. If it was greater than, that means that we only have one triangle. We'd only just do inverse of sine and be done. But because it's less than, that means we have how many? 2. And we found the 2 angles. And now that we have the 2 angles, our B, we now can find our C. Okay. So you'll have 2 separate triangles, ABC1, ABC2, and you would find their missing parts from there. So for ABC1, you have A, B. Can you find C? Yes, you have enough information to find your C now. So to find angle C, you add and you subtract, and you get your angle C is 60.8. To find C2, your other C option, you would do the same thing. Now to find side C, you're going to set up using your ratio for law of sines. No, there's only one A. There's one A, one side A, one side B, and then but there's going to be two B's, two C's, and two side C's. Okay. Now you're plugging in what you know. Solve for your C, cross multiply and divide. And we get that C1 is 24.2. So one triangle is based off of B1. And then you have your second B value that's going to produce another triangle. So this is our first triangle. We are at 10:55, by the way. I can go back. Then our second triangle, we're going to do the same thing. You're going to subtract, find your value, and we get 8.6 degrees. Set up your law of sines, plug in, cross multiply, and divide, and you get your second value of C. So now you have your two completed triangles that look like this. And you can go back. I can go back. But here are your two completed triangles, and I just wanted to make sure we got through the full exam. So you either are going to have this acute triangle or this obtuse triangle. But these are your two final options of possible triangles. Okay? All right. And then this is just remembering the number of triangles satisfies. So you want to just make sure that you are checking your A and B, checking your values of your side, and then determining which way to go from there.